So this is the amount of energy liberated by one atom of uranium. Now it's going to be hard for us to work in terms of one atom. It will be better for us to work in terms of grams. Let's try to find how much energy would 1 gram of uranium liberate. Now, to be able to do this, we will need to know how many atoms are there in 1 gram of uranium. Now, to allow us to do this, we're going to use information that we got from Avogadro's and the mole concept. The mole concept says that 1 mole of anything contains a fixed number of particles. Just like I would say one pair of socks will always contain 2 socks. So 1 pair of anything contains 2 of that particular object. Similarly, 1 mole of anything contains a fixed number of particles, and that fixed number, this is the Avogadro's number, and the Avogadro's number is 6 times 10 to the power of 23, which means that 1 mole of anything contains 6 times 10 to the power of 23 particles. So now we know how many particles are there in 1 mole. But this still does not help us for our problems. We need to convert grams into number of particles. Now the mole concept tells us another thing. It tells us that for any element, mass of 1 mole of that element is going to be equal to the AR of that element, which means that if I have the element oxygen that has an AR of 16, means that 1 mole of oxygen is going to be 16 grams. 1 mole of hydrogen, for example, is going to be 1 gram. 1 mole of magnesium is going to be 24 grams. So these values are the AR values of these elements, and the AR is the relative atomic mass, which is equal to the proton number plus the neutron number. So this is the mass number, this is the larger number that you see in the periodic table. So when we look at the periodic table, all these values here, the relative atomic mass, so these values tell you how many grams will 1 mole of that particular element weigh. So if we are going to analyze for uranium, so 1 mole of uranium will weigh 238 grams. So this is for 1 mole. So let's see how these 2 pieces of information help us for our calculation. So 1 mole of uranium, mole can be abbreviated as MOL. So MOLE, full term, MOL, abbreviated form. So 1 mole of uranium is 238 grams based on the periodic table. Now then, 1 mole of anything contains 6 times 10 to the power of 23 particles, which means that this contains 6 times 10 to the power of 23 uranium atoms, because the particles in question here are uranium atoms. So you can see how we're converting atoms to grams, vice versa. So let's see how many atoms will there be in 1 gram of uranium. So we'll do a simple proportion. So 6 times 10 to the power 23 divided by 238 grams. So this is going to give us, so from this we get the number of atoms in 1 gram. Now 1 atom produces 3 times 10 to the power of minus 11 joules. So I have so many atoms. So how many joules will that produce? So I'm going to multiply by 3 times 10 to the power of minus 11. So this gives about 75 billion joules of energy, which is huge. So as you can see, uranium, 1 gram of uranium gives us a huge amount of energy. And because it is a chain reaction, we're going to have lots and lots of neutrons that are going to be produced. So what happens is that we need to contain these neutrons so that it does not go out of control. So some of the neutrons are going to be absorbed in the reaction, in the chain reaction. We'll have neutron absorbers to prevent the reaction from going out of control.